So here's the high pressure profile that is set up by the pulsation, the oscillations of the fan on this 2018 Chevy Camaro SS2. I'm taking line temperature right here because basically that's the only place I could get a good suction line pressure. Now remember, this has an internal heat exchanger, so that changes the temperature. It's actually a little colder on the other side, but I can't get a gauge there. I'm taking the liquid lines, subcooling right here before it goes into the heat exchanger. Remember, the heat exchanger removes some of the heat and lowers the subcooling when it comes out on the other side of the line before it goes to the expansion valve. So I don't know if you could hear the fan coming off and on, but this is the fan when it goes off, and it comes on right about 127. Am I on the right? Yeah, 127. And the fan turns off at about 102, 103, 102. So right around 102 is where the fan turns off, and then it allows the high side to go all the way up to, say, 130. And if you look at our superheat and subcooling, because of the way the fan, airflow is everything. When the airflow is messed up because you have a pulsating fan, there's no way for you to set a charge using superheat or subcooling. It just varies too much under these ambient conditions, under these conditions. It's too bad that the manufacturers do not provide a software override that would override and allow you to go into a test mode so you could at least somewhat have a close idea of the charge using superheat or subcooling. Our saturation temperature, and you can see our saturation on our liquid line really jumps up and down with the pressure because the fan is turning off and on. So there's no coolant airflow, and then there's a lot of airflow, then no coolant airflow, then there's a lot of airflow. That's what's happening right here. As for temps out the dash, here we go. We're into 6 minutes now, and you can see the low side temperatures hovering right around 38, 39 degrees, 40, 38, 40. So it's bouncing between within 2 degrees. 38 and 40 degrees is what the low side pressure is staying out, within a 2-degree range. All right, guys, I'll see you later. Just wanted you to see this one because this one definitely oscillates. The high side pressures constantly bouncing up and down. Look at 1 minute. Between minute 3 and minute 4, we go from one low peak to another low peak. So every 60 seconds, we're varying between 127 to 189. How did I read that so wrong last time? Don't know what the hell I was looking at. 190. So say 190 to 130 in 60-second intervals. That's what it's doing under these ambient temperatures. All right, I'll catch you guys later.